Hey everyone, and welcome to another one of our videos. Today we're going to be doing the upper control arm replacement on my W140 Mercedes S320. The same process and same or similar parts is going to apply for any of the W140 models, be it an S320 as kind of the base model, any of the diesel ones over in Europe I believe, and the higher end 420s and 500s and 600s as well. In my case with the 320, maybe the same for the other ones, we're going to use what's Mercedes part number 140-330-7707 for the passenger side, which is where we're going to start. And then on the driver's side, we're going to be using Mercedes part number 140-330-7607 on that side. The Limfurter part numbers are 1100502009, as you should be able to see there, and 1100402009 on the driver's side. The reason I'm doing this, upper ball joint boot ripped, pretty common failure as these cars have gotten very old at this point. So replacing the whole upper arm is kind of the easier solution. I did the reboot job on the driver's side. It was a pain and it wasn't the best quality of work and longevity of work. So I'm going to go ahead and replace both sides now, given the opportunity. And these control arms from Mercedes are very expensive, but from Limfurter, who makes them for Mercedes, from my understanding in this particular case, they're not badly priced at all. So I went ahead and bought both, and I'm going to do both sides and get it all dialed in one shot. So we're going to go ahead and head on over to the car and show you what the disassembly process looks like. It's pretty straightforward. And then we are going to come back to the workbench for some of the work as well, because these control arms come from the factory mounted loose within their mounts. As you can see, it is able to pivot within the mount here. And there's some tensioning and bushings and whatnot that's done on the bench top actually for these, which is a little more involved than a lot of other vehicles where you just torque to spec on the ground or something like that. So I'm gonna go ahead and head on over to the car, show you what we're working with, and start moving forward from there. So sitting here in the fender well, we have obviously the wheel taken off of the passenger side, and we're looking at the upper control arm. It's held into the spindle just with a bolt and a pinch mechanism here. And then the upper control arm itself is held into the fender well structure of the vehicle with 4 Allen bolts in the 4 corners. One of them is going to be very difficult to see down there. And so what we're going to need to do is take loose the pinch bolt, drive a chisel into the spindle to spread it out. The upper control arm should pop up, not super violently, it's just under bushing pressure, so it'll just pop up. And then we should be able to take out the 8mm hex bolts or Allen bolts in the corners and pull the whole control arm out. It should be a pretty straightforward process. So the bolt and nut holding the upper control arm in place to the spindle are both 19mm. We're just going to take a 19mm half-inch drive ratchet and a wrench on the backside to take those loose. And like I said, drive a chisel in there to spread the spindle and let the pinch mechanism free. So we're going to go ahead and do that, and then move on to showing you how to take those 4 bolts out. Okay, so you can see we separated everything off camera. I paused what I was filming and doing to make sure that I was doing everything safely. And the reason being is because whenever you saw me start moving the pinch bolt that was in the spindle out from securing the upper control arm, it was under a good amount of tension. So what I wanted to do was lower the car down on my lift, put a floor jack up underneath the lower control arm, just to make sure that there wasn't going to be any released energy whenever I separated the upper control arm from the spindle, at least that I wasn't expecting. In other words, that the spring wasn't going to push down on the lower control arm and push anything down unexpectedly. Good news is, as expected, none of that happened. Interestingly, whenever I pushed the spindle bolt out, I also did that with a punch by hammering a punch through on the opposite side, pushing the bolt out. The upper control arm launched out of the spindle and released. So obviously some of these, and this may be from it being serviced and spread open in the past or something along those lines, some of these pinch mechanisms are not exactly pinching everything like they should be or in theory are from factory. In other words, just be aware that whenever you knock the bolt out, you might have the upper control arm come up and not actually stay in the spindle and have to knock it up otherwise. You can see just from the gap difference here, the upper control arm did release and pop up under bushing pressure. This one's actually still in pretty decent shape as far as bushings go from what I can see here. It's just the ball joint is toast, and you can see I had wrapped it up with some tape just to protect it temporarily. so I could drive it from site to site and whatnot. But you can see the bushings and whatnot are still in decent enough shape. That said, now it's time to take the rest of it out. So the control arm itself is mounted within this bracket. The bracket's held in with those 4 8mm Allen bolts. So you're going to take an 8mm hex key or socket and knock those loose. Obviously you're going to need to use a socket and possibly even on a swivel to get those out, realistically speaking. And so that's what I'm going to do. I'm going to go ahead and get those guys out, and the upper control arm should just fall out at that point basically. So we'll get that done and move on to the next steps. All right, so I have this thing set up, kind of ready to go and get tightened up. I kind of rigged up exactly how this thing needs to be set up and pre-tightened and pre-tensioned to spec. So I've got the old control arm clamped here on the workbench, new control arm clamped on the workbench. You can see the old one is held under its own tension because the bolt that goes through is torqued to a specific specification. In the case of this one, the bolt is loose. You can actually just turn it from either side, and the nut on the front side turns. So what we need to do is torque this to spec with a specific offset measured from the side of the bracket here to the tip backside of the upper control arm right there. Very odd way to tension it. And that specific dimension per Mercedes documentation, measured again from here to up there, is 63mm. So what I did to set this up was set a little machinist square here to 63mm, flushed up against the bracket where it's to be measured from, flushed a machined level up to that, and then took a square from there, and of course I'm messing all of this up now, but got the measurement set up in place. Because of the equipment that I have, there's some eyeballing involved. I needed basically to eyeball straightness of all of this against the side here, but it's pretty darn tuned in. And once I got all of that measured in, I made an alignment mark on the backside here in silver Sharpie to the bushing of the control arm there. So what I'm going to do is start getting all of this tightened. I'm going to get everything started such that the arm is able to hold itself to some extent in tension up at the top, and then I'm going to double check all of my measurements and then torque it to spec. The through bolt torque spec through here is 120 Newton meters, which is 88.5 foot-pounds. So I've got this guy clamped down to the workbench with a clamp. We'll see if this is able to take 88 foot-pounds. I don't know. We'll see. If not, I'm going to have to come up with another method of fixturing this, or I'm just going to have to figure out a different way to do it on a different workbench or in a different orientation or something. But I'm going to go ahead and get this guy set and torqued, and at that point we'll be ready to reinstall. All right, we've got this guy set up, torqued, and ready to rock and roll now. That was a real pain. Again, not sure why Mercedes did this over-engineered kind of solution and why they don't come pre-torqued if there's a factory spec, but that's neither here nor there. It's done, it's taken care of now. So what I ended up doing is using a super long ratchet on one end, having one person hold it, and another person using a torque wrench to torque it to spec. I ended up actually running the bolt down with an impact just to get it, get some tension started on the bushings so that the arm would kind of hold in place, and then that's where I was able to manipulate it, move it around, and make sure it's good to go. And what I did was both double check with my measuring tools, and I double checked using a digital angle gauge at the angle, and again, based off of the datum of the bottom of the bracket, and same on this one, match between the old and new. The old one was still set up at exactly the factory spec. Again, no real bushing wear there. It's just age and the boot tear that took this one out, really and truly. So this guy at this point is ready to go into the car. So what I'm going to do before that, and what I highly recommend you do, depending on the condition of everything that you've got, is I'm going to go ahead and put some rubber protectant on the bushings, just to make sure that those oxidize as little as possible, on the boot as well. I'm going to clean that up since there's a little bit of grease that was kind of either seeped out or over greased from factory on the ball joint. Make sure that that's good to go. Apply a little bit of grease into the taper as well, right here, and a little bit along the shaft too. And then I'm going to clean the heck out of the factory bolts. I'm going to reuse those. They came out nicely. They didn't strip out or anything. Clean the heck out of the factory bolts to get rid of the Loctite, and same goes with the holes. I'm going to clean the heck out of those in the car that the bolts thread into to make sure that there's not just gobs of Loctite in there. I will still use Loctite putting them back. I believe that Loctite is specified from factory. Either way, I'm going to put some on there, but I'm not going to gob it on like it was done here. So I'm going to go ahead and take those steps of cleanup, and then we'll get back to the vehicle for reassembly. We have the new control arm here now temporarily or partially installed, I should say. Not temporarily, because I certainly don't intend to take this thing back out again. And so we've got the arm in place, all the bolts started. Like I said, I cleaned all of the holes out using a conical wire brush or a cylindrical wire brush, and cleaned all of the bolts off using a wire brush. I actually had to run a pick down the threads to get all the Loctite out, the old Loctite. And I applied a reasonable light amount of Loctite to these to move forward with the rest of the installation. The new control arm butted up in here, no problem. You definitely want to make sure that your little bracket here that holds your either brake line or ABS line, I'm not sure which one that is. It looks like that is your ABS sensor line. You definitely want to make sure that you have that on top before you put the bolts in, otherwise you're going to need to take those 2 bolts on the left back out. But otherwise, super straightforward to get this thing back in. This would have been a 2-second job if it weren't for the fact that we have to tension these out of the car and everything. So at this point, I'm going to go ahead and tighten those and torque them to spec. Again, 8mm Allen, and if we look at our torque spec sheet, that is a 50 Nm or 36.9 foot-pound torque spec on those bolts. Nothing too crazy there. And so once we get those torqued to spec, we're ready to remate the spindle and the upper control arm ball joint. So I'm going to go ahead and get those torqued to spec and move on. We are now ready to rock and roll and get the upper ball joint secured back to the spindle. And so all we're going to do is I'm going to utilize 2 people for this because I have an extra person on hand. And what I'm going to do is move the spindle over to align with the ball joint, pull the ball joint down while aligning it with the spindle and getting everything set into place, and have the second person throw the bolt in through the side to secure everything in place. Once the bolt's through, you'll be able to let go of the suspension and everything will stay where it is, and you can worry about putting the nut on after the fact. So once we get to that point, that's where we'll come back and finalize this side of the project. Alrighty, we are just about done. All I have to do is throw the nut on and torque everything to spec as far as the pinch bolt goes. So the pinch bolt, the last little bit that we put on, the nut, that's going to get torqued to 125 Newton meters, 92.2 foot-pounds, and we're going to be done at that point. So we'll get that done. We'll come back and do a final recap and close everything out. Well, we are now done. So we have the new upper control arm fully in place. Everything's torqued to spec. The 4 bolts up there, the pinch bolt right there, and of course the center bolt, which we did on the workbench, is torqued to spec as well. You can see that all of these bolts and whatnot are paint marked. This is something that I always recommend doing to make sure that you're not loosening, and the paint actually helps jam a nut up if it does decide to start loosening as well. So it's a little bit of a safeguard too. But everything is inspection marked, so we know where we tightened everything down to. And we are ready to rock and roll, at least on this side. So this is the end of the video. I still have a whole other side to do. With that, I want to thank you all for watching. Let me know in the comment section down below if you have any questions, comments, or concerns, and I hope to see you in the next video. Take care.